Good afternoon, grade 11 students. Welcome to Fabulous Math class. Since it's already 3 o'clock, let's have our opening prayer. Amen. Okay, class, please take your seat and arrange your chairs properly. Is there any absent today from this class? Since nobody's absent today, let us give ourselves 5 claps. Okay, very good. Here's the important reminders during the class. You should actively participate in the discussions and activities. So now, let's have an activity. Guess the picture and name it. I will be going to flash the pictures on the screen and you will be guessing it. The first picture, second, third, and the last one. What have you observed from this picture? Okay, very good. This is exponential function. And for today's learning objectives, at the end of the lesson, you will represent real-life situations using exponential functions and solve problems involving exponential function. And let's proceed to our proper discussion. Our lesson for today is all about application of exponential function, where we can apply the concept of exponential functions. The best thing in studying exponential functions is they have numerous applications to real-life situations. Exponential functions can be applied to quantities that increase and decrease in an amount exponentially. These are the commonly used applications. First, the exponential growth. Then we have exponential decay. Then, the third one is radioactive decay. And the last one is compound interest. So, in this afternoon, we are going to cover each of these applications. So, now let's begin to the exponential growth. Exponential growth is applicable to quantities tend to grow exponentially and at different rates. The common application of exponential growth are the following. We have the human population, animal population, bacteria, and the number of virus. To find for the exponential growth, we need to follow this formula. P of t is equals to P sub 0 times 1 plus R raised to t. P of t is called the population at time t or exponential growth. P sub 0 is a population or the initial amount at time t equals 0 and R is rate of growth and t is time. Let's have an example. The population of small island is growing exponentially at the rate of 2% per year. Find the population of the island after 20 years, given the population is now 70,000. This problem is an example of exponential growth. It is because of the keyword growing. And to solve this problem, let us first list down the given values. We have the rate 2% or 0.02. We also have time, which is 20 years, and the current population is 70,000. Following the formula of the exponential growth, we have P of t is equals P sub 0 times 1 plus R raised to t. So, we are looking for the population after 20 years. So, we have P of 20 is equals to 70,000 times 1 plus the rate 0.02 raised to the power of t, which is 20. Simplify all of this, we have 70,000 times 1.02 raised to 20. So, based on this, we have P of 20 is equals to 104,016.32. So, it's approximately 104.16. We need to round off this because we do not have 0.32%. So, what can we conclude? Okay, very good. At the end of 20 years, the population will be approximately 104,016. The next application is a concept of exponential decay. This is the opposite of the exponential growth. This one is being used to quantities tend to decrease exponentially and at different rates. So, for the formula, we need to follow P of t is equals to P sub 0 times 1 minus r raised to t. If you're going to compare with this to the exponential growth, the only difference that here we have 1 minus r since there is a decrease in value. For our example, a population of 10,000 fruit flies is dying off at a rate of 6% per minute. How many flies will be alive after 15 minutes? Looking at this problem, we have the keyword dying off, which means this is the example of exponential decay. There is a decrease in the number of fruit flies. So first, let us have the given values. We have the initial values of fruit flies, which is P sub 0 is equals to 10,000 fruit flies. We also have the rate of decrease, which is 6% per minute or 0.06, and we also have the time, which is 15 minutes. Following the formula for exponential decay, we have P of t is equals to P sub 0 times 1 minus r raised to t. So now, we have P of 15 is equals to 10,000 times 1 minus 0.06 raised to 15. We have 10,000 times 0.94 raised to 15. Simplify this, we have the answer 3,952.92. So, this is the population of the fruit flies after 15 minutes. Since you cannot have a decimal population, we need to round this up. So, this approximately 3,953. So, what is our conclusion? Okay, very good. After 15 minutes, there will be approximately 3,953 fruit flies. Next application is radioactive decay. The common measure of the rate of decay is the half-life of radioactive substance, defined as the time it takes for the half or a particular substance decay. And to solve for this, we need to follow the formula. P of t is equals to P sub 0 times 1/2 raised to t over h. Here we have the same variables except for h, which refers to half time. And for the example, we have the half of life of a certain radioactive substance is 6 days. The initial sample is 4 grams. What is the amount remaining after 10 days? Looking at this problem, we have a keyword half-life, which means this problem is an example of radioactive decay. So first, let us have the given values. We have the initial sample of the radioactive substance given by 4 grams. We also have the value of t for the time. We're looking for its amount, and that is after 10 days, and the half of time is given by 6 days. Next, we need to follow the formula. So we have P of t is equals to P sub 0 times 1/2 raised to the power of t over h. Substituting the given values, we have P of 10 is equals to 4 times 1/2 raised to 10 over 6. Solving for this, the answer will be 1.26. So this is the amount after 10 days. So we can now conclude that after 10 days, approximately 1.26 grams of substance remains. The next application is the compound interest. Is defined as interest paid on interest reinvested. What we mean by this, the interest that has been added to the principal also earns interest. Therefore, the compound grows so fast over a period of time. Since the idea here is the interest is being compounded, we need to take note the different compounding periods. So we have annually, which is 1 period in a year, semi-annually, 2 periods, quarterly, 4 periods, and monthly, 12 periods. So to solve for the compound interest, we need to follow the formula. A is equals to P times 1 plus R over N raised to the power of N times T. P stands for the principal for the annual interest rate. N is the number of times interest is paid for, or which is called the compounding period, and T is the number of years. So, following this formula, let us solve for this problem. Suppose that 12,700 pesos is invested at an interest rate of 8% compounded quarterly. Find the amount of principal after 6 years. We have the given values. The principal, which is 12,700, the interest rate is at 8% or 0.08. And we have the compounded period. Here it says quarterly. Therefore, there are 4 quarters in a year, and then we have the value T, which is 6 years. So the next thing to do is to follow the formula. So we have A is equals to P times 1 plus R over N raised to the power of N times T. A, which is the future value, is equals to 12,700 times 1 plus 0.08 over 4 raised to the power of 4 times 6. Computing this value, we have A is equals to 20,427.15. So what we can conclude? Okay, the amount after 6 years will reach 20,427.15 pesos. And now, let us proceed to our performance task. And here's the scenario. Sam is a nursing student who conducted a research study about the cases of coronavirus disease 2019 or COVID-19 in the areas of Davao del Norte. You receive an email from her on Tuesday asking for your help with the computation part of her research. She asked you to use the current data she acquired to analyze the population decline in the first case of COVID-19. Knowing how much you enjoy solving math problems from 2020 to 2021, Sam wants you to figure out how many positive cases were recorded. If Davao del Norte has 15,000 positive cases by 2020 with a monthly decrease of 0.30%, she then asks you a favor to write a report and make a recommendation that includes compiling data on the coronavirus within the range she's given and presenting it using a graph. Sam wants to use the report to the class as a reference for her research into coronavirus disease. And also, we have a rubrics in making the graph, and this is the rubrics in making the graph. So this is the graphing rubrics. And also for your assignment, in one half sheet of paper, solve the given problem. The population in the town of Bagong Bayan is increasing exponentially at an annual rate of 4.08%. At present, the population is 101,884. Predict the population of the town 12 years from now. So this is your assignment, and pass it tomorrow. So thank you for listening. Thank you, and God bless us all.